In this video, I will show you how to build and use the mixed integer linear programming solver called CBC, which is short for Coin OR Branch and Cut, which is included in the Coin OR Foundation. Hi, my name is Frank and welcome on my channel. Let's take a look at the Coin OR Foundation. It is a non-profit educational foundation which manages several source repositories on GitHub, mostly dealing with optimization in the context of operations research. You can read it here. We, in this video, are interested in the CBC solver, and I will show you how to build a solver and how to include this in your projects. For this video, we will use Windows and Visual Studio. Our aim, for educational purposes of course, is to include this into an older project which is built under 32 bits and Visual Studio 2019. However, we will do this on a 64-bit machine with Visual Studio 2022. But the process is the same if you want to build it into a different kind of setting. As we work with GitHub and Visual Studio, please make sure that both are installed on your system. I use Tortoise Git, but you can use whatever you want to. You can even download the repository by hand if you want to. Let's take a look at the repository. You can see here the Coin OR Foundation manages a lot of projects. For instance, the CLP, which is a linear programming solver or an interior point optimizer. But we are interested in the Coin OR Branch and Cut solver, CBC. So to download it, go to the GitHub page. You can see the address here. Just plug in Coin OR GitHub into Google and you will directly come to this page. And navigate to the repository, which includes the CBC. And you make sure that you are in the master branch, but by standard, you should be in the master branch. Otherwise, navigate to the master branch here. And you can see here in the repository, there is a file included, which says MS, so Microsoft Visual Studio. And it even says here, oh, it has the files in it, so there is the project files. You need to compile a CBC with Visual Studio. So this is nice. So the first step is, let's download the repository for CBC. To do so, just copy the address of the repository and create a new folder, which we call coin-or. Coin-or, there you go. And inside this folder, we just now we use the interface of Tortoise Git, and it says here just git clone, and it immediately plug it in the copied address. And well, that's all we have to do. Just leave all the other fields blank and just press OK, and it will automatically download the GitHub repository. It takes a few seconds. There you go. We downloaded the CBC GitHub repository onto our system. So let's take a look at this. As I said, here are the files which we need to compile with Visual Studio. In the source, you see here are the source files. If you want to change something, if you want to implement your own stuff, this is the here are the source files located. But for now, just simply navigate to the Microsoft Visual Studio file. Here you will now see 6 different folders named V9 up to V16. So what does this mean? These are the different versions of Visual Studio. You have an explanation. So V9 is not listed here. It should be the 2009 version. If you see something, if you work with Visual Studio a lot, you will see these abbreviations a lot. And how to count and how to differentiate between the different toolsets, you can see a list how to do so here. So V10 means this is the Visual Studio version of 2010, which works with the toolset denoted with V100. V11 means the version of 2012, no, not 2011, but 2012. And this works with the toolset V110. Similar for V12 and V14. So V14 is the Visual Studio 2015, and it works with the toolset 140. After that, so V15, V16, and V17, which is the most recent version, you see that the toolset is increased in a different way. So here we have plus 10, plus 10, plus 20, and here we have only plus 1, plus 1, plus 1. This means only the last digit of the toolset is increased. Why is this the case? So just to give you some tips which you can Google, since 2015, so the V14 version, the versions are ABI compatible. This means application binary interface. That basically means you can compile projects of Studio 2022 with 2015 and the other way around. And that's the way, and that's the reason why only the last digit is increased. So this is just for your information. If you stumble across something with Visual Studio and you don't know how to count, here is the reason, or here's the information how to count. Okay, so coming back to our problem, we want to build our CBC project with the 2019 Studio. So this means we have to choose the V16. V17 is not listed here. They will probably update their repository in a couple of weeks or days. So let's close this and open the folder V16. You see here we have a solution, the Visual Studio solution, and 1, 2, 3, 4, 5, 6 different projects. So let's just open the solution and see what's happened. So now it's loading. And now we got an error message. It says, one or more projects in the solution were not loaded correctly. Please see the output window for details. So what is happening here? So first of all, don't be afraid about this notification. It just says, we have a newer version available. Maybe you want to update your project to the latest Windows SDK. This is the platform toolset I just explained. So V134, this is the last toolset available. However, we want to build it with the toolset V42, and this is what is written in the solution. Now that's why it's complaining here. So we just click cancel. And now you see here all the solutions, all the projects which are here in the solution. This 1, 2, 3, 4, 5. We have seen them in the folder. However, there are more projects in the solutions, namely libcgl, libclp, libosi, and so on. And they had not been found. And if you remember the homepage of the project itself, let's go back. You will see that they have a CLP repository here. And this is missing here because what we have ignored, where's my Visual Studio? There it is. We have ignored the dependencies because CBC is depending on other repositories of the CoinOR project. So now we have to install, or now we have to link at least these repositories, these missing repositories, to the CBC solution. Before we start downloading the dependencies, let's take a look at the homepage again. So here we are in the Git repository. Open the repository of CBC and you will find something like config YML. In the config YML, you will see a short description of the repository itself, and more important, the dependencies. And there we see, for instance, we will need the coin utils repository. We will need the OSI repository, which is the Open Solver interface. And we see this is actually required to build our CBC, package. So where should we put this package? Where is the solution expecting the libosi or libosi CPL package to be found? To do so, the easiest way is just simply take a look at the solution. So right click on a solution, open it with the editor, and take a look at, for instance, at the coin utilities, which we just saw. And we saw this is expected in 1, 2, 3 folders ahead, and then coin utils. So where are we when we go from this folder 3 folders above? So 1, 2, 3. Well, there we are. We are in the coin OR folder. So that's where we have to put all the dependencies, and then hopefully the solution will work and will give us a compilable package. Let's go. So let's close for now, close Visual Studio. Open again the config YML, where we see all the required repositories. Let's put it here on the right hand side and put the folder on the left hand side. And now we go through. We download only the required packages, the optional packages we just ignore for now. So first of all, we need the data sampled repository. So we just copy the URL and again clone the repository. There we go. It's done. Next, we need the miplib3. So right click, copy, and clone the repository. And here we have the utilities, and you see this is exactly where we want to put our repository. Again, git clone the utilities. A little bit larger. Clone the open solver interface. And last but not least, the coin OR and the cut generator library. Okay, and that should all we need for now. The rest is only recommended. So now it's time to fire up the solution of CBC. So go to CBC, Visual Studio, V16, and open the solution. And now you will see in a few seconds that all the dependencies are now loaded correctly, and Visual Studio is now ready to compile our CBC solution. So you can see here, since we loaded the V16, which is the V142 toolset, the platform toolset is now set to Visual Studio 2019. If you want to compile it, for instance, for 2022, you have to change the toolset here, or if you want to do it for another toolset, whatever you want to. Just keep in mind that you have the toolset installed in order to do so. Okay, our aim was to build a CBC version of 32 bits in the debug mode and for Visual Studio 2019. So we already have the debug version installed here, because I usually develop stuff with the debug version because this is easier to debug. But now we have to change to x86, which is the 32 version. So now the compiler is building the libraries for 32-bit systems. So all we have to do now is to build the solution, but this may take a while. So let's speed up this a little bit. The compiler has done its magic. Let's take a look at the output. Where is the output located? Since we are using the debug profile, the output is located in the folder where our solution is. So this was V16, and there now is a debug folder where all the compiled output is located. These are a lot of files. Let's take a look at this. For each solution, or for each part of the solution, for instance, for libcbc, we have 3 different types of files. So IDB, lib, and a PDP file. So what are these files? I've written here some stuff down to make it easier for you. So usually, if you compile something in Visual Studio, you might want to see an ILK file, which is an incremented linker file. This is only used for fast rebuilding and is not needed here. We have a so-called IDB file, which is similar to the ILK, which is a Visual Studio Intermediate Debug file. This is actually not needed. This is just created by standard by Visual Studio as we have compiled CBC. We have a PDP file. PDP stands for Program Database. And this is where Visual Studio stores debug information about a program, for instance, the symbol information. And this is actually it's not necessarily needed, but if you want to debug your solution later on and we want to step into the associated DLL or library file, then the PDP file is needed as long as you know where the location of the source code is located. If you change the location of the source code, so if you change our folder structure, the PDP file has to be rebuilt. But again, it's not needed, but it's heavily suggested to use this one. The most important part, which we are aiming for, is the lib file. This is actually where CBC is located in quotation marks, because this is where the source code is put into. If you compile something, and you will end up either with an exe, so a program you can run, or a batch file or whatever. This is now the library. It's similar to a DLL, which you might have already seen. So this is absolutely needed. Now it's time for a minimum working example, or how to put all those stuff into our test problem. So a minimum working example might look like this. We include the CBC model, load an MPS file. So MPS is just a language where you can formulate linear optimization problems in a very smooth way, and this can be understood by nearly all commercial solvers, including CPlex and including CoinOR. Then we use a branch and bound method to solve these optimization problems, and in the end we output all the computed variables. To do so, just copy the minimum working example. This can be found on the internet. It's a standard working example, and fire up Visual Studio, because we are creating an empty project. So create a new project. We use a console app, which just hello world. So a console app on Windows. So we click next, call it for instance CBC test, and put it on the desktop. I prefer to put solution and project into the same directory, but this is up to you. Now we click create. Here is our simple hello world problem. We now replace this by our minimal working example. And now you can see we run into some problems because the Visual Studio does not know where the CBC model HPP is located, and therefore cannot work with those objects. To do so, we have to include all those header files into our project. So first go to the CBC test problem, which is located here, and create a folder which is called include. This is where we want to put all those header files. The header files can be found simply by searching through our repositories we have created. So just search for h star.h star. There you go. There are all the header files. Simply copy all of them and put them into the include directory we just created. We now have some trouble because some files are duplicated, but we can take a look at them, and you see much of them are just config system and actually we don't need this. So we just stick with all those files we already have. Now we have to tell Visual Studio, hey, look for the header files in this include directory. So go back to Visual Studio, change our platform from 64-bit to 32-bit, just by simply changing the profile here. Now go to the properties of the solution, because we want to build a CBC we want to include CBC into a 2019 project, so change it to 2019, because this should be consistent with our build of CBC. If you include CBC build with 2019 with a different platform toolset than you're working with, you might run into very strange errors which are very hard to debug. So change it to 2019 and we are happy. We still have to tell Visual Studio where to find our header files. This is into the C++ path under General. There we have something like additional include directories. There we have to tell Visual Studio, hey, take a look at our include directory. So we create a new line, select a new folder, select the include a folder where all our header files are located, and press OK, press apply, and there you go. We are happy now. Now Visual Studio knows where to find for the CBC model.hpp, and for instance where to find those class OSI CLP solver interface. Just click on it, for instance press F12, and you jump directly into the correct header file where the definition, at least the header definition, is located. We are left with telling Visual Studio where to find those compiled libraries. So we now create in our CBC test file, a test folder, a new folder, which we call lib, so lib for library. And there we put all those compiled packages from CBC, so which can be found in the debug file of the v16 file folder. Just copy everything, plug it into the library. There you go. Again, we have to tell Visual Studio where to find those packages and how to include them. Again, this is done in the project properties file. Now this is part of the linker, because the linker is responsible for mapping those functions compiled in those libraries with those definitions in the header files. So go to the linker. Again, under General, you will find additional library directories similar to the header files. Click on Edit, add a new file, and now add the lib directory or lib file, lib folder, and press OK. Now we have to work a little bit more, because just because we added those directory to those paths does not automatically tell Visual Studio include all those libraries inside those folder. This is something we have to do by hand, and this can be found in the next slide, which is input. There we have a field called additional dependencies. And this is now a little bit of work, because we have to put all our libraries by hand into this field here. So take a look at this. Here we are for library package. Oh, this was too fast. For instance, we have to put those libcbc.lib into this field. So this was libcbc.lib. Unfortunately, we have to do this for all those libraries by hand. So I just speed up this a little bit. So here I put all those libraries inside those lib folder. Now press OK, press apply, press OK, and we are nearly done. We are left with those MPS file, because this is not in the correct position. I want to put all those MPS files into the folder which we call models, because it's an optimization problem. And this means we have to create a new folder inside our CBC test file, which is called model, or I call it models. And those test files are located in the folder, or in the repository. I think it was here, one of those. No, it was the other repository. It was in DataSample. Yes, it was in DataSample. In DataSample, we have several test problems which you can choose from. And here is our P0033. We can take a look at this, how this looks like. Nothing spectacular. It's just a way how to formulate a linear optimization problem. Okay, so quickly copy it, put it into our models folder, and there we go. Now we should have set up everything correctly. So let's press F5 and see what happens. There we go. That's all. We have set up CBC correctly. The linker has found everything he needed. So we have set up everything correctly. Well, and CBC is working. It has loaded the MPS file correctly. You can see it. It has read P0033 with 0 errors. And now it's computing with a branch and bound method. And in the end, it outputs the computed variables. So everything, the optimal solution just consists of ones. That's all. That's all you need to know to get a very basic, get CBC working with your Visual Studio. I hope you enjoyed this, and I hope this was helpful. If you have any question, just feel free to ask me. Write a comment, write me an email, whatever you prefer. And have fun. Have fun with CBC, have fun with mathematics, have fun with programming in general. And well, see you. Bye.